Good day, students, and welcome back to my series where I'm still having a pen to paper argument from the paper that was written recently by class of 2022. And to some large extent, I want us to have a more detailed account on every function that was debriefed on this particular paper. And that was question 4, question 5, and question 7, and also question 8. It was primarily on functions. All right. So let's check what we are going to be having here. We are going to spend some decent amount of time in here. Let's check what are we having in question 4. We are saying that sketched below is the graph of h of x, which is given by 1 over x plus p plus q. The asymptotes of h intersects at the point 1 and 2, and that is the first quadrant. That is the point there, 1 and 2. Well, we say to you that write down the values of P and Q, and we give you 2 marks. Think about it. This graph, it's a hyperbolic graph. So now, before you even attempt it, think about it. If you have a sketch just like this one, I'm going to have a graph of hyperbola, which really behave something like this. I hope you guys know it. This is the origin. This is the parent graph of the graph of a hyperbola. This is when there is no movement. All right. But what we are seeing here is that this graph, it shifted horizontally to the right by 1 unit and vertically by 2 units upward. So check. Now I'm going to shift this graph from the origin just by 1 unit to the right. So that is primarily 1 there. Let me just write 1, and then this is what we are having. I'm going to move this graph by 1 unit to the right and also 2 units upwards. So check. This graph is going to behave something like that, which is basically what you are having. I'm trying to visualize this situation for you. So we have that graph. It's what we are having. So the value of Q is going to be 2, but the value of P is the one which we are saying we are moving 1 unit to the right. So if you move to the right, it primarily becomes a negative. If you move to the right, if you move to the left, it becomes positive. I hope you know that logic. So I'm going to say to myself now, question 4, let's put it down, question 4. We have a 4.1, that means P is equals to -1 and Q is equals to +2. It's the graph of the hyperbola moved from the origin upwards by 2 units and to the right by 1 unit. It becomes negative. Check now. They say calculate the coordinates of the x-intercept of h. So we are looking for the x-intercepts. We have a 4.2 where y is given by 1 now. That is 1 over x minus 1 plus 2. So we are looking for the coordinates. Please read the question carefully. They are saying to you that calculate the coordinates of the x-intercept of h, not the x-coordinate of h, the coordinates. Because sometimes you guys have a negative tendency of not getting the question. It means here they want the points, that is x and the y. But if they say the x-coordinate, they want only the x value of that particular intercept. So I'm going to say to myself that the x-intercept of this one is going to occur when y is equal to 0, and solve for for x. Let's do it together. Y is 0. That means I'm going to have this one. That is x minus 2 plus 2. What can I do now? I can clear fractions by multiplying. This should be -1 here. What can I do now? I need to clear fraction by multiplying everything by x minus 1. That is 0 is equals to 1 plus 2 into x minus 1. Now let's solve for x here quickly. It's going to be 0 is equals to 1 plus 2x and then minus 2. And then as a result, you're going to get 0 is equals to, and then 2x and then minus 1. Therefore, x is equals to 1 over 2. Because we're looking for the coordinates, I'm going to say that the coordinates are 1 over 2 and 0. This is the coordinate. It's not the x coordinate. I'm going to emphasize this point very well. Now, let's check 4.3 very quickly. So this is 2 marks. Where do you get the marks? For the first one, you get 2 marks for that. And then this one, you must be able to substitute this correctly into the formula. That means you're going to get the mark there, and also a final representation of your work. All right. So the rest of the work are primarily subsequential. Let's check the next question. They say that write down the x coordinate of the x-intercept of g if g is equals to h of x plus 3. Okay. We are having a g. Let me put it here. This is g of x is equals to h of x plus 3. So now we are going to move these coordinates to the left by 3 units. Right, by 3 units to the left, because it's plus 3. We call it horizontal translation. That means that this point, I'm going to be having a 1 over 2 minus 3. I'm moving this point primarily, but the x coordinate of it. All right, and you're still gonna have a 0 there. And then if you type it nicely, it should be able to give you negative 5 over 2 and 0. So this is how you're going to do it. How many marks is this one? They're also giving it 2 marks. So let's check where do you get the marks? You get the mark there and the mark there. But if you want to really look at it from the graph, you are moving this graph of h 3 units to the left. Think about it. You are having a half there. That is 1 over 2. Let's have 1. Let me just have a 1 and then a 2 there. 1, 2, and then a 3. So I'm going to have a 3, 2, but they are negative, and then negative 1 here. Think about it. If you are to move this graph to the left by 3 units from half there, from the point of half, let me just delay this and show you something. From this point, if you are to move 3 units to the left, so you're going to have a first movement there at negative half, a second movement there at negative 1.5, and then the third one now, that is 3 units, is going to be at negative 2,5, which is negative 5 over 2. So you can still reason in that way that this is where this graph of g is going to be it's going to behave something like that. This is how this graph is going to behave, you know. Let me just put it here. But it will still be below the line y equals to 2. I'm just trying to draw it nicely. This is how the graph of g is going to be doing. Think about it. It was primarily here. It moved to the left 3 units in that way. So you're going to have the x coordinate there at negative 2.5, which is negative, which is let me really put it down here, which is primarily at negative 5 over 2. And that is what we are having here as a point. So you can just write the point. They are still going to give you 3 marks for that. Now, the next question, that is 4.4. What are they saying there? 4.4. So basically, question 4 was having 20 marks. They say to you, the equation of the axis of symmetry of h is given by y equals to x plus t. That means it's the one of a positive gradient, and then a plus t. Determine the value of t. You know, so let me delete this part because I was trying to demonstrate my argument. So this is the equation of the axis of symmetry. this one, you can see that it's the one of a positive gradient, but it's going to have a y-cut at t. Remember that this axis of symmetry is going to intersect with the one of a negative gradient at that point of the asymptotes. So let me really try to visualize it in this way. This is the graph there. I'm looking for the y-cut of it at that point, which I don't know, but I will find it. And then this one, we call them the axis of symmetry. Let me just really do this for you. And then even the other one, and then same stuff. Check. This is where these graphs intersect. But this one is the one of a positive gradient. It's y equals to x plus t. You know, so we can substitute the point that it passes through, that is 1 and 2, to get the value of t. How many marks? That is 2 marks. So let's really do that together to say that y equals to x plus t at a point. So the point is 1 and 2. Let's solve for the value of t there. How do you do that? You plug that point. That is 2 is equals to x is 1 plus t. Therefore, t is equals to 1. Where do you get the point? Where do you get the marks? From the correct answer and the correct substitution. That makes that to be 2 marks. All right. So that is 2 marks as well. And that is also 2 marks. And this is also 2 marks. Now let's check the next question. They say determine the values of x for which this graph here, that is minus 2, is going to be less than or equals to 1 over x minus 2. So these are free marks, eh? These are free marks. Think about it. Think about it in this way. That is 4.5. That is 4.5. They are saying that for which values of x will negative 2 be less than or equals to 1 over x minus 1. You can really do it algebraically, but it's not advisable because it's given 2 marks. Is it 2 marks or 3 marks? I will check it. So the best thing to do will be to transpose to that side and really see what you're going to be having. You're going to be having 0 is equals to 1 over, 0 is going to be less than or equals to 1 over x minus 1 plus positive 2. Think about it. This is 1 over x minus 2, minus 1, and then plus 2. This is bigger than or equals to 0. It's the same as this notation. I want to do it in this way. What is this one? This was given as h of x. So you are primarily looking for the values of x for which h of x is greater or equals to 0. What is that? That is where the graph is above the x-axis or equals to 0. Where is the graph h? 0, equals to 0, or positive. This bigger than 0 means positive. Positive means above the x-axis. So let's go and check it and interpret it. Where is this graph equals to 0? And where is it above the x-axis? So I'm going to say to myself, let me delete this work here. I'm done dealing with it. Now, I'm going to say to myself that at this point, this graph is 0. And that point was 1 over 2, right? This was 1 over 2. So this is where this graph is 0. And then where is this graph positive now? This graph is going to be positive. If you check nicely, it's going to be positive from this region going that side. So when x is less than or equals to 1 over 2, that's where the graph is going to be 0, and at the same time is positive. That means bigger than 0. But check something here. This region here, it's also above this region just right here. It's also above above 0, which means above the x-axis, I mean to say. So that means it's positive. So when x is bigger than 1, this graph is going to be forever positive. And also when it's less than or equals to half, But we can't include 1 for this one because 1 is the asymptote. We cannot touch the asymptote. Remember that. So this graph must be bigger than 1, or must be less than or equals to half, because at half it is 0. You can see that it is 0, and you can touch the half because half is not the asymptote, is the x-intercept, is defined at the graph. But at 1, this graph is not defined. So I will then say to myself that this solution for this one is going to be well interpreted to say that x is going to be less or equals to 1 over 2, or x is going to be bigger than positive 1, you know, like that. This is how you really attempt that question. How many marks is really this one? They're giving it 3 marks. So you really get that 3 marks for free. So you say to yourself now, where do you get the marks? This is where you are going to get the marks there for putting the correct answers. And also to be able to, you know, transpose that to be in that way, or you can really put it in that way. So that is the marks. That is 3 marks for you. Extremely easy, right? This is really easy. That's how you're going to go about question 4, the first 5 questions. Let's check the other one. The other one, that is 4.2. It's primarily these questions just right here. These ones, that is 4.2. They are giving how many marks there? That is 1, 2, 3, and 1. It's primarily 4.2. This should be 4.2 there. All right, so let's check. The graph of f is given by x squared minus 4x minus 5, and the graph of g is given by a times 2 to the power x plus 2. These graphs are sketched below. E and h are the x-intercepts of f. C is the y-intercept of f, and lies on the asymptotes of g. Okay, that's a good part. And the two points intersect at D. So at D is the intersection of the 2 points, and the D is the turning point of the graph of f. Okay, let's write down what we are given before we attempt anything. That is question, that is 4.2. So I'm going to start that on a new page, and I'm given that f at x is equals to x squared minus 4x minus 5. This is what we are given, and the graph of g of x is equals to, that is a multiplied by 2 to the power x. Let me really, because of space, and really put it here. And then here they are saying that is plus q, where q is the asymptotes. Okay, what is the question now? The question now, that is to say that write down the y coordinate of C. So I'm going to observe what is happening at C. At C there is the y-intercept of the graph. That means at that point, x is 0. So when x is 0 at this particular graph, what is y going to become? Y is going to become negative 5. So here, they are not, please guys, read the question. They are not saying that write down the coordinates of the y-intercept. They are very specific to you to say, write down the y coordinate of C. I'm going to emphasize that. So they want only the y value at that point, and that is y equals to negative 5. When x is 0 at that point, y will be negative 5. So this will then mean to us that 4.2.1. That is y equals to negative 5. This is what they are looking for, not these things of saying that this is going to be 0 and negative 5. This is wrong. Nah? They want the y coordinates. So be careful. In them, they give you 1 mark for that. Now let's check 4.2.2. That was 1 mark, so don't really do anything else there. they say to you, write down the coordinates. You see, they are very specific, the coordinates of D. Now we are looking for the coordinates. That means the X and the Y of D. What is D? D is the turning point of that particular graph. Okay, let's write down the coordinates of D. Okay, so this is the turning point of this particular graph there. How do you find the turning points there? And it's 2 marks, right? Is it 2 marks? Let me check it quickly. That is 2 marks. So that should really be easy. The turning points. There are 3 ways to find the X value. I'm going to do all of them, you know. So the first one is to use a grade 11 work. That is to say X is equals to minus B over 2A. And that really becomes negative B. B is negative 4 over 2 times A is 1, and that should really give you 4 over 2, and the answer is 2. So the X value at the turning point is 2. Now, for those of you who may have used a different method, you will say that the turning point is primarily the first derivative being 0. So you are going to say, let me just write or, just right here, or the first derivative at X must be 0. And if you derive this F, that is 2x minus 4 is equal to 0. This will be 2x minus 4 is equal to 0. Therefore, X is going to be equals to 2 if you solve it. This is the other alternative to get the X value at D. So it's still 2. And then let me give you another method to do this. To get the X at D, you see the X at D, it's basically this value there, D. So that is primarily your axis of symmetry there, you know, at that point. So how do you do that? This is going to be found by the sum of the X coordinate at E and the X coordinate at H. So let me find the coordinates of E and H. I'm going to say that at E and H, so at E and H, there Y is 0, or F at X. Let me just write F at X is 0 there. So that means you're going to solve for the x-intercepts of this graph there. So let's do that quickly. We are going to get x squared minus 4x and then a minus 5. That is minus 5, right? Minus 5 is equal to 0. Therefore, let's really quickly get those coordinates. That is x, 5 and 1 minus and then a positive there. Therefore, x is equals to 5 or x is equals to negative 1. So the coordinates at D, the x at D, just write x at D, is going to be the sum of the x at E. So at E is negative 1 and at H is 5, you know. So you can just somehow put it down for in case you will need it. At E is negative 1 and then at H is what? Is 5. It's what you have just found there. So when you add those two values, divide by 2, they are going to give you the X value of the turning point, which is the axis of symmetry. So let's do that. So you say this is 5 plus the other one, which is negative 1, divide by 2. It's going to really give you 4 over 2. As a result, you're going to get a 2. So you have to really use one of the 3 methods in order for you to really get the correct answer there. Let me try to reduce this for more room. Now, you will then say to yourself that these are your 3 methods of getting the axis of symmetry there. You must have used one of those 3. So to get the Y value at D, you will then say to yourself that therefore the Y at D is going to be F at 2. You're going to plug 2 there. So that is going to be 2 squared and you get minus 4 into 2 minus 5. All right. You are really going to do this, and as a result, what are you going to get? Quickly, you get 4 minus 8 minus 5, and this will boil down to negative 4 minus 5, and the rest negative 9. Therefore, the coordinates of D is negative 2 and negative 9. I want you guys to see something now. This is 2 marks, and I've done a lot. So what are they looking for? Here, they are looking for their coordinates. So that is the answer there. And to be able to get the x there at that particular point, which is really 2, you know, they'll give a mark for that to get the x value there, and to also put it correctly, because the y there is substituted nicely, and that is negative 9. So you could have used one of the 3 options. You know, I think that is the points. This is how you can do it. You know, yeah, that's how you should really go about it. That was what now? 4.2.2. We are now going to 4.2.3. What are they looking for then, guys? Let's check quickly. Determine the values of A and Q. So if you check A, it basically dilates the graph itself. It basically dilates or compresses the graph, and then Q is the horizontal asymptote of the G, which at the same time gives you the range. All right. So want to find the value of Q. So Q is going to be, check something. Q is the asymptote, and this graph is not touching the y-intercept of F, and that is negative 5. So Q is negative 5 there. That is that horizontal asymptote. So I'm going to then say that, well, it's 3 marks. So y, which is Q there, let me just write Q is equals to negative 5. Q, you just read it from the graph, is the asymptote of G. That's where the graph is not touching. That means that the graph of G of x is equals to A multiplied by 2 to the power x plus Q. You know, and then the plus Q, just put it here. But we know that G of x is primarily y. This is going to be A multiplied by 2 to the power x plus Q. Q is minus 5. How do you then get the value of A? The value of A, you are going to use the point, any point that passes through F, and that passes through G. And the point there is D, is the one that you have just found. So G passes through D, hey? So I'm going to say, well, at D is 2 and negative 9. Let's get the value of A. Therefore, we are going to get negative 9 is equals to A multiplied by 2 to the power x, and x is 2 there. So I'm just going to put a 2 minus 5. Therefore, as a result, this, if I transpose 5 this side, this becomes negative 4 is equals to 2 squared is 4 multiplied by A, so it's 4A. Therefore, my A is a negative 1. So where do you get the marks? You get the marks from getting the correct value of Q, and the correct value of A, and the correct substitution in the equation. So you get the mark there, and that amounts to 3 marks. You know, that's how you're really going to get that. This was 2 marks for you. All right, let's check the next question, 4.2.4. Write down the range of G. The range of G is primarily is influenced by the horizontal asymptote. So in this case, this graph is defined below this line of the horizontal asymptote. Is defined below negative 5, you know, but we cannot touch that line. So this graph is defined in this region. That's where this graph is primarily defined. So what I will then do is, I will say the range of this is going to be y is less than that line. We cannot include it because it's not defined at that point. All right. So I'm going to say 4.2.4. That is your range there. 4.2.4. Y must be less than the value of q, which is -5 there. And then you get a 1 mark for that. You got a 1 mark. And then let's check the next question. 4.2.5. What are they saying there? This paper was very easy. I hope you guys can attest to that. This graph was really, this question paper was very easy. Determine the value of k for which the value, determine the value of k for which the value of f of x minus a k will always be positive. Will always be positive. My goodness, what did I do there? Okay, sorry about that. Let me try to really delete it properly. I don't know what I did there. Delete even this one there. Thank you. So we're still continuing. For which values of k, determine the value, determine the values of k for which the value of that f of x minus k will always be positive. Okay. So let's really have it here. 4.2 that. For which value of k will f of x minus k will this stuff be positive? You know, so I can really say for which this will be positive. I can really say positive is always shown by an inequality of bigger than 0. All right. So what I will then do is I will say, what is f primarily? What is f? So f, if you look at it, f, the maximum value of f, remember that f is y, eh? F is y. Minus a k bigger than 0. But your f, you got it at d to be at -9, eh? This is the maximum, no, I think it's the minimum in this case. It's the minimum y value there, it's f. That is -9 at that point, all right? So let me try to really delete it. So f there is -9. So I'm going to put a -9 in that space. That is f, which is y, primarily. So I can say to myself, this is -9, and then minus k is bigger than 0. You know, therefore, minus k will be bigger than +9, and divide everything by negative. So this really becomes k is now less than -9. I don't know how many marks was this. I don't know how many marks was this. That was 2 marks. Okay. So that should really be easy. It's 2 marks. So this is 2 marks, guys. Don't stress it out. K is less than -9. I will say that you get the mark from this one, you know, and from the substitution there. But remember that this is mathematics, and there are myriad of ways to solve a problem. How can you solve this one? You know, you can say to yourself, let me write or. If I were you, I would say that, look, they are saying for which this stuff will be positive. What is this one? This one is f, right? So f was given as given as x squared minus 4x minus 5. So I can say to myself, this was x squared minus 4x, and then minus 5 minus a k is bigger than 0. Think about it. This is quadratic, eh? Where you can say this is x squared and then minus 4x plus the value of c. So your C here is primarily negative 5 minus K, bigger than 0. So we are looking for the value of that, in which this would be positive. So the value of it, we're talking about the Y value. If we're looking for the X value, you are going to use X is equals to, if you're looking for the roots primarily, you are going to use a B squared minus 4AC. But this time around, we're looking for value of K, for which this value will always be positive. So what is that? What is this one? This one is primarily, the value of this is going to be the Y value of it. How do you then get it? Think about it. You are primarily talking about something like minus B over 2A, and then here you're going to have 4AC minus B squared over 4A, This is where you're going to get the maximum. I think here it's going to be the minimum of it. So now what I will do is I will take the Y value of it, which is primarily going to be B. Let me just use that one primarily. It's going to be 4AC and then minus B squared divided by 4A. It should be bigger than 0 as per questions. For which value of K will this stuff bigger than 0? So let's just substitute what we have here. This becomes 4 into A. A is 1 times C. C is negative 5, negative K there, minus B. So B is negative 4 squared divided by 4 over, 4 into A. A is 1, bigger than 0. So let's apply ourselves here. This really becomes a negative 20, and then negative 4K there, and then negative into 16, that becomes a negative 16 divided by 4 is bigger than 0. Think about it. You're going to get a negative 4K, negative 20, and negative 16 is negative 36 divided by 4 is bigger than 0. If you really divide everything by 4, this would be negative 4. Think about it. Divide everything by 4. This is really going to be negative K and negative 9 bigger than 0. Therefore, you will get negative K bigger than positive 9. You divide by negative, you get K is less than negative 9. This is the other alternative that you may have utilized in the exam room. That's how far I can go with this one. You see, I'm giving you two methods of it, so you can't really get it wrong here. Where will you get the mark for this one? For you to be able to plug it correctly on this formula here and to be able to get the correct answer. The rest of the work really is subsequential. It's a futile exercise primarily, but I'm doing this for the benefit of your attention. You don't have to really overwork like this because there's no time in the exam. All right, let's check. We are done with question 4, which makes my life easy now. We are going to question 5. Okay. What is happening there in question 5? They are giving you the graphs of g of x, which is given by 2x plus 6, and the graph of the inverse, which is g prime there, and the g inverse of that graph is the inverse there of g, are shown in the diagram below. D and B are x and the y-intercept respectively of g. Okay, it's a straight line, guys. We can't really struggle to do this. C is the x-intercept of the g prime, which is correct. The graphs of g and that they intersect at A. The first question, what are they saying? Write down the y-coordinates of B. You see? Write down the y-coordinates. They don't want the the coordinates of the y-intercept. It's not the same thing. So they want y equals to, it's the y-cut of the line primarily, which is 6. You know, when x is 0 at that point, y becomes 6. So let's put it down. Let's put it in writings, and I'm going to say to myself, we're now doing question 5. We are now doing question 5. That is, we are given the g of x primarily here, which is 2x plus 6, and the g inverse of x we are not given. So 5.1, write down the y coordinates of this graph. So it's when x is 0, so y becomes positive 6. Not the coordinates, please, the y coordinate. And then 5.2, what are they saying there? This seems to be very easy. It's a straight line. Determine the inverse of g, okay, the equation of the g, of the g to the power negative 1, which is the inverse, in the form of g to the power negative 1 of x is equals to mx plus n. So that is a straight line as well. Okay, we can't really struggle to find the inverse. I'll say to myself that the g of x is given by 2x plus 6. And then now the g, the g inverse of that, it's primarily going to be interchanging the x and the y. All right, that means you are going to get x is equals to 2y plus 6. Therefore, you will get the 2y equals to x minus 6. You divide everything by 2, you get y equals to 1 over 2x and minus 3. Therefore, what they are looking for is the g, is the inverse of g, which is given by negative 1 over 2x. And my goodness, what am I doing? This should be a half x and then minus 3. That should be a half x minus 3. How many marks was this stuff? Let me check the marks before I do anything. So that is 1 mark and 2 marks. So the other one is the coordinates of A. Okay, what's up at A? At A is the intersection of the inverse and the G itself. So you're going to equate the two graphs and solve the coordinates of A. But check something. At A is the third quadrant. So everything should be negative when you solve it. Don't get anything from that. I mean, outside that stuff. So this means that this is our G inverse. So where do you get the marks? This is 1 mark. Obviously, is the y value there. And then now, to be able to interchange x and y there, and to be able to get that equation, I think they're going to mark it this one in the form of this one. So that is 2 marks. And then 5.3. 5.3, the coordinates of A, that's where these two graphs intersect. So I'm going to say at A is the intersection of G and the G inverse. I'm going to equate these two graphs and solve for x. Therefore, I will have a 2x plus 6 is equals to 1 over 2x minus 3. And as a result, I'm going to multiply everything by 2 to clear fraction. And that is 4x plus, this should be 12, I guess. This should be 12 equals to x minus 6. Therefore, this should be 3x is equals to, you transpose 12 that side, it really becomes negative 18. If my math serves me very well, therefore x becomes negative 6. And you want to get the y, you can plug the y into that graph or the other one. So y becomes a 2 into negative 6 plus 6, and that is a negative 12 plus 6 is negative 6, right? So therefore, the coordinates of A is negative 6 and negative 6 as well. How many marks? Let's check how you're going to be given the marks here. It's 3 marks. Okay, it's really 3 marks. Let's mark it. It's 3 marks. To be able to equate the two graphs carefully, and to be able to get the value of x and your coordinates, to really put it as a coordinates like that, not the x and the y coordinate. I hope you are learning, eh? Now they say calculate the length of AB. Well, the length of AB, you can't fail to do that. It's the distance formula. The answer is 2 marks. It's really easy. So I'm going to do it in a simple way. The B there, it's 0 and 6, and A, we have just found it, and there's 2 marks. Hey guys, this is 2 marks. So I'll say that this is 5.4 primarily. So this is 5.4. You want to find the length of this one. And the B now, it's 0 and 6. You are going to use a distance formula. Let's do it. We get -6 minus 0 squared plus -6, -6. You square that, and that is 2 marks, so you don't have to really sweat a lot here. So I may as well need to reduce this and say that is going to give me 36. 36 plus 144, because that's -12 squared, so that is 144. As a result, we are going to get 180, and you square root 180, it's going to give you 6 the square root of 5 in my imagination, because that is 36 times 5, and that is 6 root 5. So that is the length there, you know. So therefore AB, because you guys, you know these things very well, you can say, or you round it off, it's going to give you 13.42, because this is the length. You can just write units. That is 2 marks. So to be able to get the right answer, the correct substitution, that makes that to be 2 marks. 5.5, 5.5. What are they saying? 5.5. We are halfway done, guys. 5.5. Calculate the area of the triangle ABC. The area of a triangle ABC. Okay. Apparently, ABC is a triangle. So let me just do it in that way. Okay. That is a triangle, apparently. So let me just really make sure that those are my coordinates. Those are the points. Okay, I'm just trying to be accurate here. Well, you want to find the area of this triangle. So how do you find the area of a triangle? In fact, let me allow me to really draw this triangle. Let me redraw it carefully. That is 5.5, the way it is. Let me redraw it. It really takes this format. This is what we saw. Yeah. This is how this triangle behaves. You have A there, that is -6 and -6. And then you have a B there. B, you found it to be 0 and +6, right? And then C is somewhere there. That is 3 and 0. C is 3. Let me check C, eh? I don't want to lie to you. What is C? C C is the x-intercept of the inverse. So from the inverse, when x is 0, from the inverse, when y is 0, from the inverse. So this is the inverse. Okay. Let me put it here. The G inverse. The G inverse was 2x minus, that was half x. What am I doing? 1 over 2x minus 3 is the x. I want to find the x-intercept here. That should be 0. 1 over 2x minus 3. Therefore, x at C is going to be 6, positive 6, right? Okay. This is how you will redo that. So at C, let's delete this and write it properly. Now it's at C, that is 6 and 0, that is C. You were asked to find the distance of AB, and you found that to be 6 square root of 5. You want to find the area of this triangle. So this triangle is not a right angle triangle. So I'm going to use the arguments from paper 2 to say I'm going to use the area rule. I want to find the length of AC, the distance of AC. If you are to find it nicely, it's going to be the square root of 12 squared, which is 124, plus 144 plus 36, which is the same as 180, the one which we got previously. It means here is 6. Okay, here is 6 square root of 5 is the distance of this one. And how do you find that distance? This one, find the distance there. That is going to be the square root of 36 plus 36. So that is somewhere like 72. Yeah. 36 times 2, I think it's really going to give you 6, the square root of 2. You will definitely correct me if I'm wrong, but I see I'm correct. I trust my capacity. I trust myself very well. That distance will give you 6 square root of 2. So how do you find the area of this? You need to get at least one angle in that triangle. You can get that angle or that angle or that angle, but you can see that this triangle is an isosceles triangle, because this one is equal to this one. So it becomes an isosceles triangle. So let's find this angle. How do you find it? You are going to use the cosine rule to say that BC squared is equals to AC squared plus AB squared minus 2 AC multiplied by AB cos of the included angle, and that is angle A. What is BC squared? So BC squared is primarily 6 the square root of 2. You square it, and that really becomes the square of that. That is 5 there, squared plus the same stuff. So I may need to really duplicate this one. And then I say minus 2a. A is 6 root 5. Let me, in fact, copy everything and really put it this side. That is going to be 6 square root of 5 cos of angle A that you are looking for. So therefore, this will really pen down to 72 to, that is 180 plus 180 minus, this one should be 180 cos of A. All right, so we're almost done, guys. If you bring this one this side, it's going to be negative 288 is equals to negative 360, and then you put a cos A there. Therefore, divide everything by that. So this will ties down to cos A is equals to, if we divide this by that, it's going to be giving you 4/3. Please be careful, it's a positive situation. So you are looking for the angle. Therefore, the angle is going to be equals to 36, it's going to give you 8698. Don't really round it off for now. You may really round it a bit later. I don't have to round answers off because it may really affect my answers, you know, so I don't want any complications. You are definitely going to get this one now. And then now, how do you find the area? If you have the angle, so it's going to be, let's put it down now. The area of a triangle ABC, this is going to be equals to half multiplied by the opposite sides and the included angle, that is angle A, right? So that is AB times AC. So it's going to be AB multiplied by AC multiplied by a sine. We're using the area rule, the sine of A. And that should ties down to half into 6√5 into 6√5 sine of that angle, that is 36. Don't round it off. So that is 36,8698 ... So you can just write the whole thing there, and that should really boil down to, if you type it nicely, it should really give you 54 square units. This is the area, so it should be a square units or a unit square. So that was 5 marks. Where do you get the marks? Of course, the right answer, you must be able to get it, and the correct substitution there on that one. And then the other marks will be able to be, it's 5 marks, remember that. So I'm trying to check where you're going to get the marks to be able to use the correct sine rule. It's now 3 marks. And then the last one now will be to get the angle A, and to be able to get the sides of the sides of the remaining BC and AC, and that stuff makes it to be 5 marks. That's how you will go about question 5. Yeah, we've been here now. Question 5. Let's go to question 7. Okay, that is first principle. Maybe we are going to refresh a bit here with first principle. Question 7, that is to determine the f prime from the first principle if f at x is equals to x squared plus x. Okay, 5 marks. So these are the questions that you must not skip in the exam. So I'm going to write a question 7. Question 7. So we want to do this from the first principle. 7.1, you are given f at x is equals to x squared plus x. Now you are going to say to yourself that f prime at x is going to be equals to your limit as h tend to 0 of f of x plus h minus the function itself, that is f of x, divide this stuff by h. Guys, this should be very easy for everyone to do. It's a common question. So you have the limit as h tend to 0. You substitute everything. You substitute x plus h in a position of x here. So you are definitely going to get x plus h. You square that, and then plus x plus h. You see minus the function itself, that is x squared plus x there. You divide this by your h. and this will really give you the limit as h tends to 0. You need to try to expand this stuff, and to do this will give you x squared plus 2xh plus h squared. You still have your plus x and then plus h there. You remove the brackets there. This becomes negative x squared and negative x. You divide this stuff by h. You can really simplify your like term in the numerator. So you get, let's see what you get. You get some term being there. Some terms are going to undo each other here. And that is this term and that term are going to undo each other. And this term and this term is going to undo each other there. You are left with 2xh plus h squared divided by h. This is what you are left with. All right. Let's see if you can do it further. So let's try to take out the common factor there in the numerator. That is h. We are left with 2x plus 1 plus h. You have to divide this by h. All right. So you will see that this is going to be the limit as h tends to 0. Check something here. This h and this h are going to undo each other, and you'll be left with 2x plus 1 plus h. Now you close this stuff, and this will really give you now as h tends to 0. That means this becomes really 0, and you are left with 2x plus 1 as the answer. So let's check, where do you get the marks here? You get the marks, of course, for the final answer there. And to be able to really use the correct formula, the correct substitution there, the correct substitution in there, and that is now 3 marks, right? And to be able to simplify that to this space, that makes that to be 4 marks. And then now you need to be able to factor out your h there. That is 4 marks, right? And to be able to get that step and your final answer there. And that should really give you 5 marks, right? That's how I will work it out. Extremely easy. Well, we are now doing 7.2. What is the story there? They are saying that determine f prime at x if f at x is equals to 2x to the power 5 minus 3x to the power 4 plus 8x. Okay, that is 3 marks. Guys, this should be very easy for everyone. Let's check. We have f at x, which is equals to, you are primarily given that is 2x to the power 5 minus 3x to the power 4 and then a plus 8x. This is what you guys are given. So you want to find the derivative, the first derivative. That is going to be 10x to the power 4 minus 12x to the power 3 and then plus 8. So where do you get the marks? You get that, and that should really ties down to 3 marks. This is how they are going to mark you guys. And then 7.2, what are they saying there? This paper was very easy. This paper was very easy. Now, where is it? Okay, the tangent, the tangent to g, which is g at x is equals to ax cubed plus 3x squared plus bx plus c, has a minimum gradient at the point -1 and -7, for which values of x will g be concave up. By the way, this is a cubic graph, so you're given the g and the point at the gradient situation, for which values of x will this guy be concave up? Okay, let's try to do it together here. What are we given? We are given g of x that is equals to ax cubed and then plus 3x squared plus bx and then plus c. And this graph has a minimum gradient. This graph has a minimum gradient at a point that is a -1 and -7. All right. So for which values of x will this graph be concave up? Think about it. This is a cubic graph which is likely to behave like this if a is positive. And if a is negative, this graph is going to behave like this. So for concave up on this graph is going to be influenced by the point of inflation there. That means from this region like this graph is going to be a concave up, and it's going to be a concave down like that. So if I can get the point of inflation there, then I'm fine. And then for this one, this is going to be a concave up if a is negative. So that means we need to get the sign of a here. We need to get the value of a. It's going to really determine how far we can go with this question. So how do you then do that? The gradient is going to occur at the second derivative, right? So I'm going to get the first derivative. That is really going to give me 3ax squared plus 6x plus b. You know, the first derivative really gives me where the graph is going to increase, you know, and decrease. That's where you get the first derivative. And also the first derivative really assists you to get your stationary points, which is the turning point. So the gradient, you are going to get it from the second derivative, right? And that is to say that if you derive this again, it's going to give you 6ax now plus 6. So we are going to have a gradient at a particular point. So let me just write that. The gradient is going to really occur at x is equals to -1. This is where I'm going to get the gradient in there. So I will then say to myself, therefore, the g double prime at -1, that should really give me 0. You know, that should really give me 0. So let's substitute -1 in here to say this becomes 6a into -1 plus 6 is equals to 0. This will then give me the value of a, you know, this will be -6a plus 6, which is equals to that one. Therefore, a is going to be a positive situation. So my a is positive. That means this graph is going to have a concave up. I'm gonna redraw it again for you. So this graph is really going to behave like this. Let me do it now primarily. So this graph is really going to take this format, you know. So the concave up is influenced by the point of inflation in here. So how do you get the point of inflation? Primarily, because if I can get the point there, then I'm done. I just need to say from here going upwards, it's really going to be a concave up. So this point of inflation, that is where the second derivative, is equal to 0, you know. But you found that stuff to be this one. So I'm going to say that therefore 6ax plus 6 is equal to 0, but a is 1. So I will say therefore a is 1, that's going to be 6x. If you plug 1 there as a, let me just put it for you. It's going to be 1 multiplied by x, and then plus 6 is equal to 0. Therefore, you get 6x is equals to negative 6. So x is going to be equals to negative 1. This is the point of inflation. That means x there is negative 1. So because a is positive, this graph is going to be a concave up from negative 1 to positive infinity. Therefore, let me read the question again. It's important to read the question. I'm going to respond to the question now. For which values of x will g be a concave up? So you say to yourself now that the graph of g will be concave up when x is bigger than negative 1. When x is bigger than negative 1, you're going to have a dull situation. For those of you who love interval situation, you can just write, no, don't write or, you write only one solution. But the other way to do this is when it's when you put your answer in this fashion. It's correct. One of the two is correct. But for those of you who love maths like myself, you can just really approach it in this way. You know I love maths, so I can have a array of ways to really solve one problem. Think about it. The graph, if a is positive, just write since a is positive, that means this graph is going to be a concave up. It's going to be a concave up if g prime at x is positive, you know. So therefore, you're going to have your 6ax plus 6 is bigger than 0. Therefore, a was 1, so you get 6x plus 6 bigger than that one. And then as a result, you're going to get x is bigger than negative 1, you know. So this is how you really write it. And then let me just also write this one. You must write one option, you know, must write one option here. It's either you write this one or you write that one. Don't write two of them. You write one. So where do you get the marks? This was how many marks? I didn't really check the marks, guys. How many marks was this? This is 4 marks. So we have a lot of steps, guys. This is 4 marks. So let's check, where do we get the marks? You get the marks, you know, from the second derivative, you know, and to really show them that the gradient at that point is 0, and to get the value of a as well. So that is 3 marks so far, and then your 1 mark for that stuff. So that makes it to be 4 marks. So this is how far I'll go with the with question 7. With question 7. This is how far I'll go with it. Yeah, we've been here for some time, guys. Let's work out the last question. That is question 8. Okay. They say to you that the graph of y equals to the f prime at x is equals to mx squared plus nx plus k is drawn. The graph passes through the points P. P is negative 1 over 3 and 0, and Q is 1 and 0, and R is 0 and 1. I want you guys to see something here, that at P is the y is the x-intercept, and also at Q is the intercept, the x-intercept, and at R is the y-intercept. Okay, so they say to determine the values of m, n, and k. You are given the intercepts. My goodness, you are given everything just right here. So I'm just going to 6 marks. Okay, question 8. Let's do it together. Question 8. Question 8. Let's check question 8, guys. This is really easy. 8. Let me just write what you are given in question 8. So you are given y equals to f prime at x, and that is equals to mx squared, and then plus nx plus k. You're also given the point P. The point P was -1/3 and 0, and Q was given as 1 and 0, and at least that was R. R is 1. No, it's 0 and 1. Is it 0 and 1? I think it's 0 and 1. It's the y-intercept. Let me check it again. Hey, I need to check it. P is that, -1/3 and 0. Q is 1 and 0. And R is 0 and 1. Determine the values of M and K. But check, Q and P are intercepts, x-intercepts. So I'm going to use the intercept formula for the quadratic, because this is quadratic. I will then say to myself that this is a y equals to a into x minus x1 into x minus x2, where x1 and x2 are the x at P and Q respectively. Therefore, y equals to a into x minus x1, that is minus 1/3, which becomes 1/3. It's a positive situation there, into x minus 1. So how do you get the point? How do you get the value of a? You use one point that passes through f, that is R. So I'm going to say at R, which is 0 and 1, I'm gonna plug R here. So this then tells me that I'm gonna get 1 for y, which is equals to a into x. X is 0 at R. I'm gonna have 0 plus 1/3 into 0 minus 1 there, and then we want to solve for a. Therefore, y equals to, this is 0. Here you get a -1, so it's -1/3. So that is -1/3a. Therefore, divide by -1/3 or multiply by -3, you get a is equals to -3. That is a. So you need to plug back your a here and get and expand it primarily. So let me really copy this one down. Just gonna put it here. A, I have it now as a -3, so this will be -3 into x plus 1/3 into x minus 1. Therefore, this will really be y equals to -3 into, if you try to expand this, it should really be very good. With expansion, you should get x squared. I'm looking at it. And then minus 2/3x. And then this should be -1/3, if my math serves me very well. Therefore, multiply everything by -3. This gives you -3x squared plus, now this is 2x, and then a plus 1. This is how far. Yeah, that was a nice problem. But it's grade 11 work the way I'm looking at it. Grade 11 kids can do this question. So you get this equation. So this was given in that format, in this format. So you just have to pick up what are your m and there. So you can see that your m is going to be -3, and your n is going to be 2, and your k is going to be 1. So this is how you really work it out. It's 6 marks, right? So let's see where you get the marks. The value of A must be correct. The value of M must be correct. The value of N must be correct. The value of K must be correct as well. So where is the other 3 marks going to come from? To be able to write this graph in that way and to be able to get the value of A to be -3, you now have 5 marks, and the other one will be to be able to expand this one, and that is there, and you get everything to be 6 marks, guys. That was 6 marks. Yeah, really easy. That was 8.1 the way I'm looking at it. So that was 8.1. The next question, what are they saying? That is 8.2. I didn't check the question. We've been doing these things. If it is further given, you're given that f, the original graph basically of this one is negative x cubed plus x squared plus x plus 2. Determine the x coordinates of the turning points of this graph. Okay, let me delete this one. Determine the coordinates of the turning point. So remember that this is a cubic graph. It's going to really have the turning points at the x-intercepts of this graph. You know, this is where this graph is going to have the turning points of from, I meant to say, it's going to have the turning point at 1, x is equals to 1, and a -1/3. So A is positive primarily. No, A is negative. They are giving it to you here. A is negative. So you are going to have an ugly shape like that. But let's do it nicely. So you just have to substitute the x coordinates, the x-intercept values of f prime into f to get the corresponding y values, because the x-intercept of the first derivative is going to give you the x coordinate of the turning point of f. I hope I make sense there, and you also know that principle. Okay, we are halfway done, guys. So they give you f at x. They give you f at x, and they're saying that it's negative x cubed, and then a plus x squared plus x plus 2. You know, so the x of the turning point of these guys are at x is equals to -1/3, and x is equals to 1. Even if you want to find them, you still gonna get them, but it's 3 marks, so it's not worth that stuff. So the corresponding y value will be f of -1/3. That is going to be negative of -1/3 cubed plus -1/3 squared plus x is -1/3, and then a plus 2. That is plus. Let me check if it's really plus 2. I don't want to make a mistake, you know. Yeah, that is plus 2. So we're fine with plus 2 there. And then we just need to type it in our calculator. Let's see, what do we get? Therefore, y equals to, if you type it nicely, it's going to give you 49/27. Let's get the other one. So the other one, I may need to really copy this one and duplicate it because I'm tired. I just need to put the other value there of x. I can't just be writing this time and again. So this should be f at 1 there. And then this should be 1. This should be +1. And the y value has to change primarily So this is 3 and this is 0. So this will really give you 3. And this is 3 marks situation. Therefore, the turning point, which is TP, when x is negative 1/3 and 49/27, your right end, when x is 1 and corresponding y value is going to be 3. So let's check, where do you get the marks? You get the marks from pulling the coordinates properly and getting the y values there. That makes that to be 3 marks. Well, is there any question? I'm almost tired. That was 8.2. That was 8.2, guys. 8.2, 2.1, okay. So now we are saying, they are saying 8.2.2, draw the graph of f, indicate on your graph the coordinates of the turning points and the intercepts with the x-axis. Okay, they want the intercepts basically and the turning points. So that was 8.2.1. We are now in 8.2.2. We want to sketch this graph. So with the turning points, we just need to get the intercept of it. Okay, so f at x is equals to negative x cubed plus x squared and then plus x plus 2. Okay, the y-intercepts, so y-intercepts are going to occur when x is 0. Therefore, this graph is going to pass through. When you put 0 there, you're going to have 0 and positive 2 for the y-intercepts. You are now looking for the x-intercepts. X-intercept is when y is 0. Let's equate that graph to 0 and solve for them. That is negative x cubed plus x squared plus x plus 2 must be 0. Therefore, you can divide by negative. That is x cubed minus x squared minus x plus 2 is equal to 0. You just need to solve for x here. You can factorize this by inspection. So let's get that. Let me check. When x is 2, this is really going to be 0. So I may really do this and enlarge this one to say that this is x negative 2. This becomes x squared because these two, they must give you that stuff. And then you solve for b. B is going to be primarily 1. So that is plus x plus 1. I think it should be minus 1. Is it plus 1 or minus 1? I think my apology should be really here. So that that should really be, I'm trying to be very careful there. Yeah, I think negative 2 times 1. This one, they should really give you negative 2. And then these two give you x cubed. And then this one and this one is negative x squared plus x squared is negative x squared. So I'm fine. And then now the one of x is this one, that is x minus 2x is negative x. So correct. So my memory is still fresh to get that factors. Therefore, x is equals to 0. I mean, that factor must be 0. Or x squared plus x plus 1 must be 0. Therefore, x is equals to positive 2. Or this side, there is no solution. You can just write since the discriminant is less than 0, so we won't have any roots there. Therefore, the intercept is 2 and 0, and what now, and 0 and 2 for y-intercepts. So I'm gonna really draw this graph. Okay, this graph is really going to behave like this. Okay, A is negative primarily, so this graph won't really, it will have one intercept, right? But A is negative. Please get that. A is negative. So I may need to really have that shape. Let me really draw it nicely. It's really going to be like this, you know. And then you have that. And then it's going to cut at positive 2 there. So that is 2. And then the y value there at 2. So the y value there at 2. I'm trying to be very smart here. So that is 2. The y-intercepts. And you also need your turning points. That is 1 and 3. And you also need that point. That is where you get negative 1 over 3 and 49 over. You got 49 and what? And over, I think, over 27. So this is how the graph is really going to look like. I hope it's a very beautiful graph, and the work is also beautiful. So I'm just going to write F. You know, that's a beautiful work in my imagination. Cool. Let's check the next question. What are these? Yeah, we've been doing these, guys. I'm a bit tired now. We say that 8.3, the points E and W are two variables. The points E and W are two variables. Hey, these are two variables. Points on the F prime, which is the one that is drawn here, and are on the same horizontal line. Okay, are on the same horizontal line. H is a tangent to F prime at E. It's a new graph primarily, that H, which is a tangent to a new graph, to the parabola graph, the first derivative graph, and G is a tangent also to the first derivative at W. H and D intersect at A and B, which is D there, which is D. The coordinates are A and B. Before I go to the question, allow me to redraw this and try to analyze what they are saying there. That is 8.3. We were doing 8.2, right? So we are now in 8.3. Allow me to redraw this thing because I can't be going up and down. In fact, let me have a beautiful parabola which behave like this. I want to redraw that graph. So let's check. We are going to have this shape. This is how the graph is like apparently looking like. So we have those points. So hey, let me go and check those points. But what I can tell is that there is the turning point. There is the turning point. Let me relook into that graph again, the X there. But oh, is this one of negative 1/3 and 1, 0 and 1? Okay. And point E and W are two variables on F prime and are on the same horizontal line. Okay, let's try to visualize it in this way. Let me have another line, which is horizontal. This line may really be here and may really be here. It depends on where you want to put it. You know, let me just put it here, just right here, and have minus 1 over 3 there, and then here it's 1, here it's also 1, you know. Yeah, check something. they say that there's a point E and W which are on the same horizontal line. So they're probably here, the point E. Let me grab a point E there. And the other point is primarily W, which are on the same horizontal line. So they are a tangent. Let me show you something. They are a tangent. So this is the F prime graph. This is the F prime graph. So there's a graph of G, which is a tangent to this one. If I'm to draw a tangent line very carefully here, let me draw a tangent line like this. I hope it's a tangent line, but it must really behave carefully, guys. It must touch at one point only, which is at E. And there's another tangent at W. So let me draw the tangent there. I guess this is really clean. Okay, so these guys, they intersect at D. This is where they intersect at D. D is A and B. So this is where they intersect. I'm not really sure if I'm really drawing it nicely there. Just trying to be very careful. I'm just trying to be very careful, guys. I see my line is no longer a tangent, so I need to really draw it nicely. Yeah, it must be a tangent. I think even this one is no longer a tangent. Let me make it a tangent, a proper tangent. Yeah, you really forgive me for a jungle. Okay, it mustn't really touch that. It must not touch the y-intercept primarily. Okay, guys, I'm not touching this one because if I touch, it won't be a tangent anymore. So I may as well need to delete these dots so that you can see that I'm not touching. I'm touching at one point only. Apparently, we are going to intersect these two lines at D, which is A and B. That is A and B. Okay. This is how the graph, apparently, this is the situation, apparently. And then let's just really have a certain line there, which is called the axis of symmetry. That is my axis of symmetry line. You know, this is how I'll try to visualize this one. I guess make it a bit bigger. Yeah, I think that way it's fine. Okay. What is the question? What I just drew there, it's what they explain there. They say write down the value of A. The value of A. So it's 1 mark. The value of A. The value of A there. It's primarily the axis of symmetry. You know, they want the axis of symmetry of this graph apparently. So A will be. Can you see that the axis of symmetry is parallel to the y-axis? That means x remains constant throughout. This one is parallel to the x-axis, to the y-axis. That means x remains constant throughout at that line, even at D. So they are basically looking for the axis of symmetry here. So I will say 8.3.1, A is going to be the axis of symmetry. How do you find that? You add these two values and divide by 2. That is -1 over 2. -1 over 3. Plus 1, you divide this by 2. that should really suffice to, I don't know. You must really be very careful there. That is 1/3. Let me verify. Negative 1/3 plus 1 is 2/3. Divide by 2, that is 1/3. Or you can say, let me just write or. I want to give you possible answers here. So A is equals to minus B over 2A minus B. What is B of this graph? That was minus 2, right? So the B was 2. We divide this by 2A. What is A? A, that was a negative 3 of this graph here. Remember that this F prime situation, your F prime, where can I put it? My F prime, this was negative, that was negative 3x squared, and then a plus 2x, and then plus 1. This was the graph of this situation. We had to even find it. So this really ties down to negative 2 over negative 6. And this would give you the value of A to be 1/3. Or you can say that this A there, this A here, it means here it's A as well. At this particular point, it's A. So this means that, let me just write or. This means that F prime at A is equals to negative 3A squared plus 2A plus 1 there. So you want the axisymmetry of this one. So you're going to derive it again. That is F double prime at A must be equals to negative 6A plus 2, but this must be 0 when you derive it. So that is negative 6A plus 2. Therefore, 6A this side is going to become 6A is equals to 2. And as a result, you are going to get A is equals to positive 1/3. That's how I will work it out. There are lots of ways to really do this type of questions. So it's 1 mark. That is 1 mark. Whether you use this method, they are all 1 mark. These are all 1 mark situations. These are all 1 mark situation. Okay, so this is really easy. What is the next question? 8.3.2. I guess this is the last question, guys. We've been here for years now. Determine the values of B for which H and G will no longer be a tangent to that graph, will no longer be a tangent to this graph. Okay. The values of B. Okay. Let me recopy this work. Let me recopy it so that I don't really keep scrolling up. It's tiring. So I have the work here. So let's really delete this, and let's really remove some of the things here that we don't need. Okay, this one I don't need at all. But now I know that the point D is 1/3 and B. So I'm looking for that for the value of B for which this will no longer be a tangent. So think about it, guys. If I move just like this graph here, this H, if I move it less than that value of B, I'm no longer going to be a tangent, but I'm going to be a secant. That means now, even if I move it like this, the other one, these graphs are no longer a tangent. They are now secant. They are touching at this point. Let me put it with a different marker. At that point, and at that point, and then this one, and then this one there, that point. So when b is less than when b is less than the y value at that point, so how do you get it? You are going to substitute it into this equation that you have there. So it's going to give you the corresponding y value. All right. At that situation. I guess this should be very easy. So 8.2.2, I will then say that y equals to f of 1 over 3, but this is the f prime of it, and that equals to negative 3 into 1 over 3, all squared plus 2 into 1 over 3, and then plus 1 there. So what are you going to get? You are going to get 4 over 3, you know. So when you really, because that is the point there, the turning point. So it means that here at the turning point, you have 1 over 3 and 4 over 3, just right there. The moment you go less than that value of the y, of the turning point there of f prime, that's when these guys are no longer going to be a tangent. So therefore, b should be less than 4 over 3. That's how I will work it out. And where do you get the marks? You get the marks there. And to be able to substitute it into that equation, and that makes it to be 2 marks. And thank you very much, guys, for watching. Don't forget to subscribe to the channel for more mathematics content in Mzansi context. Don't forget to share this link to your friends as well, so that they can watch and see how far they have gone, and to the grade 11 as well, those who will be doing matric next year. Just give this link for them so that they can watch. And thank you very much for staying with me for this duration.